You can do. Alright, this is what I did. I read 4 by 2 meter machine, bird's eye view. This is 4 meters, 2 meters, and then I assumed that the gangway was a path that ran around the outside of the machine that was of constant width, so I drew it here. First of all, I tried a few ways with ratio, tried a few ways with comparing the ratio, just getting bigger, and that didn't work because that won't work with the shape, and a few other ways didn't work. We know that this here is the same all the way around. I called that X to start with, but then rather than laying the shape out like that in the middle, and then the rest of the question stated that this area here was equal to 9.5 meters. Check that. That's the question, yeah? That's what I'm going to do. Rather than drawing the inside shape here in the middle and trying to work around those outside pieces and have these corners here to try and calculate, because that's X and X, and trying to work it out like that, I'm going to redraw the shape. So rather than drawing it like that, I'm going to have a square in the middle, and then I'm going to bring that down to that bottom corner. So this now is my shaded area, which is still going to equal 9.5 meters. I've just moved the machine into the corner. Imagine if you just push the machine over in the corner of the room. This is still 4, this is still 2. You call this 2x and x, but actually I'm going to revert back to just calling it, rather than calling it 2x and 2x, because that gap is now the top and the bottom, so that should be 2x. I'm just going to revert back to calling it x, because it's an unknown in a minute, and then we'll just remember to halve it later. So that's x, and that's x. And very simple, just like when you're times in two numbers together. So if you had in this top corner 34 times 12, you can lay that out by going, here's 34, and that is 12, and you lay out your multiplication grid, and you go 3 times 1 is 3, so 30, that's 300, 10 times 4 is 40, 30 times 2 is 60, 2 times 4 is 8, and then going okay, well therefore 34 times by 12 is equal to 300, 60, 40, and 8. Going 8. So when doing a big multiplication in your head, we're going to do something very similar to that, which is just multiplication, but here we're going to do it with our unknowns. So down that dotted line and that dotted line, we have, this is 4 by x, so that's 4 times x, which you can write as 4x. This here is 2 times 4, which is 8. This is 2 times x, which is going to be 2x. And this is x by x, so x times x, that's going to be our x squared. Haven't halved it yet, no. The next thing I did then is you could work out the whole area, which is going to be our 9.5 and our 8. So the whole area to equal 17.5. Or you can work out just the shaded area, which is the way I'm going to do it, and it's exactly the same either way you do it. So just this shaded in area is going to equal to 9.5. So when we set that up into our equation, pop it here, we have x squared plus 4x. So we've done that one, plus 2x. It's got to be equal to 9.5. And this is the algebra equation that I set up. How we solve it. Collect these two together. X squared plus 6x equals 9.5. This is where we can't solve it straightforward. We have to use that quadratic formula which I was talking about. If you can't find the quadratic formula, this is it. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Shed, stop laughing. That's your quadratic formula. Okay, what the Joe's laughing, sorry. Okay, what we mean by the quadratic formula is if we have something to work out in this form, what we have is, I'll give you a really simple example. We've got x squared plus 5x plus 6. If we had to solve this at equals to 0, because you solve it when it's set equal to 0, what you can do is you can factorise that into two brackets. Yeah. And we've got your x squared terms, come here and here, so you've got x and x. So when they expand through, you've got x times x. And that's got to be times by that one's got to be times there, and that one's got to be times there. And then we need two numbers that times together to make 6. So I've got 6 and 1, 2 and 3, and they've got to add together to make 5. So here what happens is we're going to have a 2 and a 3, because 2 and a 3 add together to make 5. Signs are both positive. So what we've got there is we're saying that x equals minus 2 and x equals minus 3. I'm sorry if you don't understand this. Hopefully you might be able to have seen this sometime before. And what that is saying is this quadratic here, in terms of x and y, when you plot that on a coordinate graph, what we have is we have an x squared, so it's going to be a U-shaped graph on an x squared, and its roots are going to be at minus 2 and at minus 3. So what we're probably going to end up having is something similar like this. However it's going to look, there are two roots, we're going to get a curve a bit like that. That's a quick example of what we're doing. We're going to get two answers. So when we're solving this equation here, we're going to get two answers, but we can't use them both because, for instance, these are negative and we can't have a negative length. So we're looking for one of these to be positive, and we're going to use the positive length. The last thing we've got to do here, though, is we're not set it equal to 0 yet, so we can't use the quadratic formula. So all we have to do is subtract 9.5. So we have x squared plus 6x minus 9.5 equals to 0. Okay, I can't find two numbers that times together to make 6, like in this one. 2 times 3 makes 6. I can't think of two numbers that times together to make 9.5 that add together to make 6. I just can't think of a whole number, so it's not going to be easy. So I'm going to use the quadratic formula, which does it, so I'm going to use that instead. It will work, even for this. If I put these values here, my example above, into this quadratic formula, it would work. But we can do it an easy way, because we can just do it that way, and we can see it come out straight away. We don't have to go to this effort. But here on this case we have, okay, x squared plus 6x minus 9.5 equals 0. Things here, we've got a, b and c in our formula, and that refers to ax squared plus bx plus c equals 0. That's the general layout of a quadratic equation. Here, our quadratic equation is an x squared and an x and has a constant c. So what we're going to do is, what is a equal to? Well, here our a is equal to 1, because that's 1x squared, so a is 1. B here is equal to 6. C here is equal to minus 9. Okay. Sub it into this quadratic formula here. I'll pop it on the side. I won't go too slow because you can hopefully pause and slow this down, or watch it again. So I've first of all got minus b. So minus b is minus 6 plus or minus the square root b squared, so that's 6 squared, which is 36, minus 4 times a, so 4 times 1 times c, times by minus 9. So what I've got there, and then I'm going to divide that by, that divides by 2a. Divide by 2a, 2 times 1 is 2. So the quadratic formula is this. That can be simplified down. Minus 6 plus or minus the square root of 36. 4 times 1 is 4, times minus 9 is 4 lots of minus 9, which is minus 36. So I've got